Okay, in this video I'm going to talk about the last of the single bonded functional groups, and that would be a family of molecules known as amines. Um, so amines are typically considered as an ammonia derivative. And the one thing I did want to point out to you is this here. So ammonia, NH3, three hydrogens bonded to nitrogen, leaves a lone pair on the nitrogen. And so in the amines, this lone pair typically is still there. So that's going to give rise to some interesting geometries in the amines, but it's because of this lone pair. The other thing about amines I want to draw your attention, I'll do this right away, is that we also have primary, secondary, tertiary amines. And so here they are, primary, secondary, tertiary. And the classification revolves around the nitrogen. And so here's our nitrogen in a primary amine. Remember, these R groups can be carbons. And so basically with a primary amine you have a single ligand or carbon containing accumulation of atoms bonded to the nitrogen. So a primary amine would have an NH2 attached to it, associated with it. A secondary amine on the other hand, so here's our nitrogen. It has two R groups or ligands bonded to it, so it only has a single hydrogen. And finally, a tertiary amine then is going to lose that last hydrogen and have no hydrogens attached to the nitrogen. Is going to have three different ligands. So primary, secondary, tertiary amines. You'll come across those as well, and we'll classify those as we go along in the video. Just a quick little tidbit about amines. They're typically really stinky, so they have this very strong odor. Here's an example, putrescine. I think you can imagine what that smells like. Not very nice. This is actually, though, a diamine, characterized by two amine groups or amino groups. So this group can also be called amino. And so a diamine like putrescine is really smelly. Something else, I mean, you happen along this scene on a beach. This picture is actually from British Columbia. There was lots of dead salmon, and so the smell of rotten fish arises from two different amines, dimethylamine and trimethylamine. And so here we can classify these. So dimethylamine, here's my amino group, and I have two ligands. Here's a ligand, there's a ligand. So this is a secondary amine. Trimethylamine, there's the ammonia. 1, 2, 3 methyl ligands. That's a tertiary amine. Anyway, all that aside, dimethylamine, trimethylamine, they do not have very nice smells, and they originate from the breakdown of tissue in salmon, amongst other things. So I do want to talk about nomenclature, of course. Nomenclature for amines, we know the system now, so it's pretty straightforward. Just considering primary amines first, we look for the longest chain, and so if we look at this example, there's the longest chain, and that's a 1-carbon chain, so that would be a methane parent molecule. And we're going to replace the E of our alkane name with the suffix amine. And so this molecule becomes methanamine. Here's another example, and so here is my longest continuous carbon chain. So that's a 3-carbon chain, so that's a prop, so it's a propanamine, but now we have to indicate bond or position of the nitrogen as it attaches to the chain, because we have 1, 2, 3 carbons. And there's other possibilities, as we'll see in a minute. So we have to indicate position, so this becomes propan, you guessed it, 1-amine. Okay, what would be an isomer of propan-1-amine? Well, this would be an isomer of propan-1-amine, and so I think you can see why that would be called propan-2-amine. Again, the amino group, this amine that gives it the name, is attached to carbon 2. So propan-2-amine. Secondary and tertiary amines, the naming is slightly different. We've already seen this one. This was, if you remember, propan-1-amine. So I'll just write that again, propan-1-amine, and it is a primary amine. Well, now we've replaced one of the hydrogens with this ligand. So this ligand is a methyl ligand. Everything else is the same. So this simply becomes methyl propan 1 amine. And so it's a secondary amine because the nitrogen has this propane group, which makes it a propanamine, but it also has another ligand, carbon-containing ligand, a methyl group. So methyl propan 1 amine. The methyl is the branch. Here we have another one. We do have a second ligand, so there's our methyl group still there. Here's an ethyl ligand on a propan 1 amine. So this becomes ethyl, alphabetical. Notice methyl, the second branch, but it's in brackets, and everything else is the same. Propan 1 amine. So when you have a tertiary amine like this, the second branch is going to be in brackets and it's listed alphabetically. That's why we listed the ethyl first. So a few other things to observe when trying to name amines. A little bit more nomenclature. We can talk about the NH2 group as being, as I already mentioned, an amino branch. And so that simplifies things in some instances. Here's my amino branch, and it's on a propane. So naming that becomes 2-amino propane. So I think you see how that works. You've already seen this molecule by another name, and that was propan 2-amine. Propane, the amine group on carbon 2, propan 2-amine, so 2-amino propane also works. This will also be treated as, we can treat this as an amino group, and we would number the carbons accordingly, 1, 2, 3, to minimize the triple bond. We number this way, and so what we have is a hexane. That's a 6-carbon chain, triple bond, so it's a hexine, and we have an amino group on carbon 4, so it becomes 4-amino hex 2-ine. Okay, so that's treating the NH2 group as an amino group, and typically it's only an amino group when it's a NH2 attached. You would not see this with secondary or tertiary amines. A few other names. Again, numbering. Here's my amine, so I'm going to number the parent molecule this way. So that's a hex, and I have a methyl, so that becomes methyl hexane 1 amine. So hexane 1 because the aminos, or the N is attached to carbon 1 of the longest chain. Well, here's an isomer. Here's still I have my methyl branch, but it's the N is attached to carbon 3, so that simply changes to methyl hexane 3 amine. Finally, here's my tertiary amine, and the branches. That's a methyl branch, that's a methyl branch, and what do I have here? 1, 2, 3. So, and on carbon 2 of that, I have a methyl branch. So this becomes a little more complicated. It becomes dimethyl butane 2-amine. So in fact, I look at my longest chain as 1, 2, 3, 4, and that's a butane, but it's attached to carbon 2. So dimethyl butane 2-amine, that's what that is. Lastly, amines and polarity. So once again, we have to look at the functional group, and an amino group is slightly polar. For sure, the delta N for the NH bond is 0.9, so that's a polar group. There's also some slight polarity with the carbon-nitrogen bond, but this really is the important component that gives rise to polarity. So amines will always have that bond dipole and hence a molecular dipole, so they're polar molecules, but the boiling point is not affected quite as much. So if we again look at propane versus ethanamine, so 42 molecular mass is about the same, so we're only looking at the polarity, and so the polarity of the group here versus no polarity in the propane, and so that's why we have a higher boiling point. This polar group will establish forces of attraction with other ethanamine molecules. So if you compare the boiling point of ethanamine with ethanol, something with also has a polar group, What we're looking at here is an OH with polarity, so that's going to be delta negative. And basically the difference in boiling point, which is quite large, is due to the strength of the intermolecular force, the force of attraction between the hydroxyl group on neighboring ethanols. And that intermolecular force is a lot stronger. So molar mass is about the same, but the strength of the dipole in ethanol is larger. But that said, amines will have slightly higher boiling points than similar molecular mass molecules like propane that are nonpolar because of the polar ammonia group. So that concludes this video about amines. We've dealt with nomenclature and polarity, and that is all we are going to talk about in terms of single bonded functional groups.